Hi everybody, let's learn how to find the area between two curves, or otherwise find area of curvy shapes, or curvy area here as I'm calling it in the video. So for this video, you're going to want your graphing calculator because there's a few parts where you're going to have to do it on your graphing calculator, and we'll check your answers tomorrow. This video goes along with these two half sheets, where I'm going to do this half sheet first, and then the second video goes with this half sheet, which are the examples. So this first half sheet, you want to make sure you have that taped down, and you're going to fill that out as we go. Before I start doing that, let me tell you more of an intro of what's actually happening in this video. So whenever you were in geometry class, we could find the area of common shapes just by using the geometry formulas. So that was all fine. You could use any formula on the MCAS sheet or in a geometry book and you were good to go. However, not every shape that we would want the area of in a real life situation is not all of them are as simple as like a square or a rectangle or a circle. There are many irregular shapes that you would want the area of. Like for example, if you're a car mechanic or you're designing a car and you want to find the area of a car part, or making a plane and you want to know the area of plane parts, even something just like an airplane wing, if it looks something like this, and you knew what this curve was, you wrote a function for this curve and you wrote a function for this curve here, you could then find the area and use that whenever you are designing it and finding materials. So those are just some examples of when you would want to find the area between two curves. Let's build up the method of how you actually do this. I'm going to do it a little more intuitively with you before I actually give you the formula. So before we think of calculus, let's just think of pictures and shapes here. So let's say this is for example 1, this is the graph here, and I want the shaded area between the two curves from A to B. So A is my leftmost point, B is my rightmost point. I want this purple area. Now let's not think about calculus for a minute, and let's just do it with shapes. So first I'll draw it all with shapes. One way that we could get this purple area is if we took this entire area here from the x-axis up to the top curve, which is F, that would be yellow. And then I took away this lower area from the x-axis to G, which is the green area. So you take this entire area and then you shave away G, which is this part, get rid of that, and you're left with this floating pink or purple part, which is what we want the area of to begin with. Well, okay, now let's rewrite this with calculus. I know that the area under F from the x-axis up to f of x, that's just the integral, the area under the curve from the x-axis up to the curve, and it's from A to B. Then I want to subtract the area under G from the x-axis up to G from A to B. Well, that's just the integral of G. And there we have it. I do the integral, and this is one property of integrals here. I can combine them with one integral symbol here, f minus g. So if I did the integral from A to B, and I did f, which happens to be my top curve, minus g, which happens to be my bottom curve, I'll end up with the exact area between them. So now let's do two other situations here. So that was this one. Now let's move on to the next one here. For the next one, let's see what happens. Here both our curves were above the x-axis. What if one of my curves is below the x-axis? So F is still above, but this time G is below. Now, I still want the shaded area between the curves, still from A to B. And again, let's think of it just with shapes again. However, this time the x-axis is running between the two sections, so it cuts this shape in half here. So let's think about this area from F, or from the x-axis up to F, and I'm going to make that yellow. And let's add this chunk down here from the x-axis to G. Let's add that green area. If I took this area, whatever number that is, and then I took this area, except I'm going to want the positive of this, or the absolute value of what this area is, because I want to add these two positive numbers together to get one entire larger positive area. So before we can go to the calculus, the F1 is fine, like that area from the x-axis up to f, that's just the integral from a to b of f of x. That one's easy. The thing is, I want to add on whatever this area is as a positive number. Well, think about signed area. This actual area itself, because g is below the x-axis, this is a negative area. If I want to add it on, I will have to subtract it. because this, remember, is a negative quantity, and subtracting a negative is the same as adding it. So I take the integral of f plus, well, in this case, it would be minus the integral of g, so the area from the x-axis to g. Subtracting this negative quantity is the same as adding. And that will give me this entire purple area here. Remember, we only want positives right now. And lo and behold, it's the same as before. The integral from a to b of f minus g, where f happens to be my upper curve and g happens to be my lower curve. So make sure you get that down. Pause the video as needed whenever you're doing this. Our next situation is going to be, what if both of our curves are below the x-axis? So now on our half sheet, I'm down here. So next one. For the last example here at number 3, both of our functions, like I said, are going to be below the x-axis here, so they're both negative. As before, I'm going to want the shaded area between the curves, which I shaded in purple here, from my left endpoint A to my right endpoint B. Now, you can see it's going to end up being the same thing, but let's see why. Intuitively, let's just think with shapes here. What if I took, in order to only get this purple area, what if I took this entire area from the x-axis all the way down to this lower curve, which is G, which I drew here? That's the entire thing. And what if I took away or shaved off this part here, which is this green area, the area from the x-axis to F? So if I took the whole part and I shaved away this upper piece here, that's going to leave me with only the purple area, which is what I want. Now, whenever I'm doing this manipulation here, I'm considering only the actual positive areas, okay? Now realize that because of signed area, once again, these areas are actually negative quantities because they're below the x-axis, but I want to be thinking of them as positive amounts. So I'm going to have to do a little manipulation here to make them positive. So I'm going to represent the area from the x-axis all the way to g as the integral of g of x from a to b. It's the area under the curve, or from the curve to the x-axis in this case. And because I want to be considering this area, like the actual positive area, I'm going to do the opposite of it, or negative, because this itself is negative, and minus a negative will be positive. Then here's the minus sign right here, that stays the same. And then also this area is actually negative, but I want to be thinking of it as a positive amount. So I'm going to put a negative in front of it so that this negative and this negative area will cancel each other out, so that this thing in here will be positive. So minus a negative ends up being plus, so I have negative g plus the integral of f. They both have integrals here. I'm going to switch the order of them. So f will come first, g will come second. F is positive, g is negative, and then I use properties of integrals where I can put them together with one integral sign because they're both from a to b. And look at that, it's the same thing again. So it ends up being the integral from a to b of f minus g. That gives me the exact area between f and g. Notice once again, f is the upper curve. It's the one that's higher up when you're scanning up and down the paper. G is the lower curve. So the last thing that you want to write down in your note sheet right here, the moral of the story, here's the actual rule. If I want the area between two curves and it's from A to B, where A is less than B, so A is always on the left here, you're going to set up the integral and you're going to do the top curve minus the bottom curve. Don't forget the dx, the tiny, tiny width. Now remember, top curve, I just mean it doesn't matter where the curves are. So again, it says no matter where the curves are placed, this curve could be here, this curve could be here. Whichever one lies on top when you're scanning the page up and down. This is your top curve and this is your bottom curve. Even if they happen to both be below the x-axis, this is still the top curve and this is the bottom curve. Okay, so make sure you get that rule written down. The next video will have the examples that are on page or your second sheet.